Hi, and thanks for joining us for Hot Topics with Hot Rod, heat exchangers in hydronic and plumbing systems. I'm Erin Holohan Haskell, president of heatinghelp.com, and we're thrilled to partner with our friends at Caleffi on this webinar. Thank you to Team Caleffi for all of their hard work behind the scenes and for their commitment to industry education. And thank you to our teacher tonight, Bob Hot Rod Rohr, who is joining us from his workshop on Know-It-All Circle in Draper, Utah. Hot Rod has over 35 years of experience as a plumbing, radiant heat, and renewable energy contractor, and we appreciate him sharing some of that knowledge with us tonight. Thank you, Hot Rod.
Yeah, well, thanks for that nice intro, and thanks for inviting us along to do the presentation tonight and being part of the fun. But yeah, so we moved from Know-It-All Lane, which by the way is named after my wife, not me, just so people are clear on that. And we moved to Utah here about 4 months ago, back to Utah, and now we're going to call it Know-It-All Circle because we live in a little cul-de-sac. So yeah, this is going to be a fun topic. Let me go through a little bit of the housekeeping slides here on the front end, and then we'll get right into the material. So, and thanks for the pre-submitted questions. I did some research today, so hopefully I'll have a good answer for all the questions that you sent in. Yeah, just some tech support things from the people at GoToMeeting. If you're having trouble, sometimes if you reconnect, sometimes it's connection issue. If you can't see the slides that I'm showing, or it's herky-jerky or whatever, sometimes just log out and log back in, and that'll clean it up. Yeah, I'll share my slides at the end of the presentation. There'll be a little survey, and if you click that you want the slides, we'd be glad to send them to you. And we'll put this up on our YouTube channel, usually a couple days to a week before we get that on our Caleffi YouTube channel if you want to share it with somebody else or view it at a later date or something like that. So, all right. Oh yeah, we're going to keep tooting our horn about this angle mixer that we won the 2021 AHR award on that. If you haven't tried one of those, give it a shot. That's one of our new mixing valves that we have for pretty much any application, tankless water heaters or regular water heaters. All right, so what kind of got me motivated, this is one of my favorite topics. I've been playing with heat exchangers my whole life, making them, modifying them, just playing around with them. So we decided to do our Hydronics number 29 on this topic, and many of you know John Siegenthaler does most of the heavy lifting on those. So he put this issue together, and it kind of triggered things for me. So I kind of, I'm going to do it a little differently. I'm going to give you kind of my spin on heat exchangers from a contractor's point of view, as opposed to, Siggy's more of an engineering slant on his writings and articles and stuff like that. So I will steer you to this if you want more technical information, like sizing formulas. Siggy's all about the math and the formulas, so certainly there's plenty of them in Hydronics 29. So if you need more information on the math and stuff behind it, I'm not going to get that deep, certainly in the time that we have tonight, and that's better left to the engineers, I think. But know too that there's a lot of help out there. I'm not going to present myself as a foremost expert on heat exchangers, but there's websites. In fact, I Googled around today. I went to Aqua Laval and a couple of the others trying to get some answers to some questions that you guys had sent in, guys and gals had sent in. So yeah, there's plenty of experts. Bell & Gossett's been doing a really good heat exchanger webinar as part of their training series. I sat in on that a couple times, so certainly there's experts out there if you need some more assistance. And the Hydronics issues are now available as a digital version, so you can still get the hard copies. If you sign up today, you can get the hard copies mailed to you if you like them that way. They're still on our website as a PDF. And now you can do it as a virtual. We can kind of just scroll through it, and you get that kind of sound like a page is turning when you scroll through it. So however you want to read the Hydronics, they're available to you. And yeah, jump on the wall. I think I've been hanging on the wall as long as the wall's been in existence, 20, 30, 50 years, it feels like sometimes. But a lot of good conversation goes on there. Thanks to Erin for steering the ship and keeping that so fun and entertaining, and a lot of knowledge there. A lot of old timers still hang out there. If you need steam advice or anything like that, this is still the premier site to go to get in touch with the people that are still pulling the wrenches, doing the stuff, writing the books. It's a great resource for everybody. So thanks, Erin, for that. And the giveaway today, for one of the members of the audience, as we get to the question at the end, this is one of Dan's finest writings, in my opinion, of classic hydronics. So, and Congratulations, agreed to pass one of those along to somebody today. So thanks for the giveaway. And it ties in with the topic pretty nicely too. And also, signed copy of Hydronics for all the attendees tonight. If you register for Hydronics, go to our website and register. We'll get you a signed copy of Hydronics 29. So how's that? All right, so heat exchangers. Those of you who have been in the business, on whatever part of the business you're in, installing or selling or manufacturing, there's a lot of different types of heat exchangers out there. I mean, just look around you. There's everything you do today. If you're in your car, if you're in your home, there's heat exchangers all around of all different types. I'm going to try and just focus on ones that relate to the hydronic industry. We won't get into air coils or anything like that. And there's plenty to talk about there. Manufactured ones as well as homemade ones. These are a couple of my favorite homemade heat exchanger pictures that people have sent to me. The one on the left, I visited a mikveh in Brooklyn, New York once with Moses. Some of you guys probably know Moses Fishman. He likes to talk. And this was one that he built that goes under the steps down into the mikveh, and a real high performance because they drain those and they have to heat up the water as quick as they can so they can use it again. So it heats up, I'm guessing, like 1,000 gallons of water in a short period of time. I think Cal, who did the control on that, said 2 degrees every 70 seconds or something, with a huge boiler and a huge pump to drive through that homemade copper heat exchanger on the left there. And then on the one on the right, you'll see that commonly in guys that do solar wood boiler work. They'll make just a big open tank out of something, plywood, concrete blocks, put a liner in it, and just wrap up a bunch of coils like that and parallel pipe them so they can get a lot of flow through those. And the key to both of these obviously is copper, one of the best conductors we know, and surface area. It's always going to be a surface area game, whether it's a homemade one, whether it's a plate type, shell and tube, indirect tank. It's all about the surface area. So we'll touch a little bit on sizing and how we can measure performance, and we'll go through these slides here. So of the most common types that you're going to see out there, the shell and tube, commonly that's referred to on the plan as STHX, shell and tube heat exchanger. On the right there, you'll see a flat plate. That's usually FPHX, is a common way that you'll see a flat plate spelled out or specced out on the thing. And then you've got a shell and coil in the center there. Now, they all have pros and cons, like everything in life, in our industry for sure. There's trade-offs. You know, which one would I choose for what application? And that's what I'm going to go through tonight, is why would I choose a shell and tube as opposed to a flat plate? So places that you'll see these used commonly, snow melt systems sometimes, if you're trying to isolate the glycol from a boiler. Heat pumps, a lot of times you'll have a little desuperheater on the heat pump. Domestic hot water generation, that's getting to be a really big application. As we see more and more of these combi ModCon boilers, because the ModCon boilers just have a little plate heat exchanger inside of them that when you go and turn on a faucet somewhere, a flow switch triggers that, either a relay or a zone valve or a second pump or something like that, and it generates instant domestic hot water from your boiler. So good to know that those are out there also. I think pool heat's probably one of the biggest ones. If you're doing saltwater pools, they actually make titanium type of heat exchangers. So there's a lot of different special applications, special materials that they can make out of them for custom things. So yeah, so these are the common ones that we see. That on the left there is an example of the copper coils that I just showed you on the previous slide. What they'll do is they'll put multiple coils in here. Some of these coils put heat into the tank, so the boiler will feed into this tank with one coil, and then you can pull heat out for your heating or domestic water out of another coil. So you can kind of customize these tanks. There are some formulas I've found out there for, you know, the heat exchange of this here. It gets a little tricky trying to figure out a heat exchange rate when you have a tank of still water. And not only do you have a tank of still water, but you've got a stratified tank here. So you can see that as the coil is seeing the cold temperature down here, the heat exchange is going to be different than it is at the top of the tank where it's warm. So I know Tom up in Maine still makes these tanks. I'm thinking of his company, Solar Techniques up there. He still builds these tanks and sells them, and he's got some good formulas. And he's also got a formula that if you wanted to use PEX tubing instead of copper tubing, because of the cost, of course, it takes about, he's calculated, it takes about 3 times as much PEX tubing to get the same heat exchange as you would out of copper tubing. So you're going to fill that tank up with tubing if you're going to try and make a heat exchanger out of an insulator, which is what PEX tubing kind of is at the end of the day. It's not a great heat transfer material, but with enough of it, obviously we do radiant heat with it, so it can work. One of the most interesting tanks out there as far as an indirect tank are these reverse indirect tanks. You've probably seen this. So basically what we're doing here is we're putting the boiler water in the tank, and then we're running the domestic water through the copper coils. Now, again, the key to that is having a lot of heat exchange surface. So if you ever cut one of these open or you see a cutaway of one of these, it's just jammed full of copper tube in there. It's an expensive go right now with the price of copper, but that's how they can generate so much water so quickly, is they just have a really good heat exchange surface area. And if you crank that tank up to 180, 190 degrees, you certainly have a good thermal battery there. Now, that being said, you can still run these at lower temperatures if you do the math. And actually, I know Pierre up at TurboMax has a good software program that his family developed. And if you tell them what temperature you want to run this tank at, if you want to maximize the ModCon boiler and keep in the condensing mode, and you give him all that information, what your input temperature is going to be, what your delta T that you want to run, he can crank this out and size these tanks right down to the exact application. So I would steer you to either one of the reps for TurboMax, have access to that software, or I know he's a pretty approachable guy. If you talk to Pierre directly, he can help you special application sizing these reverse type of indirect tanks, which they make up in Canada still. And then probably the most common one that you see out there is this type here, where we've got a coil inside of a tank, an indirect water heater, we would refer to that. It could be a small version of that. I think Everhot still makes a little small copper version of these indirect tanks, but those, again, really any energy source could put heat into that, and then you typically use them for your domestic water. It could be used as a buffer tank. You know, you could put boiler input into that tank and use the water for going to a micro load, for example, so you're not short cycling your boiler. So it's really just a heat exchanger. Just because it says indirect water heater on it doesn't necessarily mean it has to be used for domestic water. It can be, and they do get used as just a large supersized heat exchanger, if you will. So this is kind of an interesting, I've actually built a couple of these at my own shop at our place in Missouri. Is you just use a flat plate heat exchanger, and if you size this heat exchanger properly, you can actually make an instantaneous water heater. So as soon as I turn on a faucet, this little flow switch will energize here, which basically just turns on this pump. So it'll take temperature out of a boiler, out of a storage tank, out of a solar collector, whatever your energy source is, runs it through the A side, let's call this the heat exchanger, as your domestic water goes through the other side, and sized properly, you can do instant hot water up to maybe 3-4 gallons a minute or more if you have enough horsepower basically to drive that. So it's a very simple way of adding a domestic water module, if you will, onto a tank of water. And again, you've got it separated. You're not using this tank water to go out to your potable water, to your faucets. You're actually using the water as it flows through the plate heat exchanger. And that's really what's happening with the combi type of ModCons. They just think of this as the ModCon over here, and they'll just have a pump or a valve, or some have a little toggle valve in them that they can just, when you start, flowing water, same thing, a low flow switch, I would say about a 0.5 GPM flow switch. So if you turn on just a little, maybe a lab faucet or something like that, you have enough flow there to trip on your pump and trip on your energy source. So the nice thing about this is you're not storing domestic water. So if you've got people that are concerned about Legionella, having water, sitting in a tank at maybe a vacation home or something like that, where the temperature goes down, they're worried about bacteria growing in there. Very little, probably less than a gallon of water is held in this heat exchanger. So if you just open a faucet somewhere in your house, when you get back to your home, you can flush this out quickly and not have to worry about that. And these will kick on quickly. The ones that I built at my own place, within 5 seconds of opening a faucet, of course, depending on the piping length, the hot water was coming out of these. Just super performance, very high efficiency out of these flat plate heat exchangers because of the surface area. You see as we go along, it's just got a lot of place in there to do that exchange. So those are some of the pros on the side of the flat plate heat exchanger. So recently, I saw somebody posted, I think this was on one of the social media sites. I didn't even know this was out there, but apparently Utica Boiler, ECR Utica, makes this hot water module. So basically, there's everything you need in there that you connect your boiler side or your solar side or your wood boiler, whatever your heat source is going to be, to one side of this, and you take your domestic water. Everything is in there. The controls in there, the pumps in there, the flow switch in there. So it's in a nice insulated box, and you just put it on the wall and you make 4 connections, and now you've got a domestic hot water generation. In fact, I think it's even got the label on there. Now Caleffi makes the exact same thing for the European market, because what these are used for is there's still a lot of district systems over there, district heating systems in a lot of the cities in Germany and Italy. And some people, when they build a new apartment or a flat complex, they'll put in a district system. And so then every unit, every apartment or every flat would have a module like this for their domestic water. So they come off the district system here. They go through the heat exchanger, and that's how they generate their domestic water. And these are called satellite units. We make them for heating. We make them for domestic water. We've got combination modules that do both domestic hot water. They do the heating. Some of them will have BTU meters on them so that you can bill the tenant based on the amount of hot water, the amount of heat that they actually use. In fact, we've got one that has the ability to meter the cold water that goes into the building, meters the hot water because that's coming off the district system, and it also meters the heating water. So you pay for all those things. You get, however much water you're using to drink or water your lawn or whatever, you pay for that. The hot water you're paying for, and of course you're paying for your heat. So really, at the end of the day, when you have multiple apartment units like that, that's the most fair way, is you pay for exactly what you use instead of just getting a assigned dollar amount every month for energy. In fact, some of them that I was saying over there actually have a card reader that you put your credit card into it, and you pay for your energy before you use it. And if you're in the shower and the hot water starts running, it means that you used up your, however, it's like a parking meter. You got to kind of go out there and re-up it. So that way, whoever owns this district system is getting paid, in real time, basically, for the water, for the energy that you're using. So it's a pretty common way of doing it. And as a result, there's a number of companies that make these modules where everything is all engineered and all sized properly. So if you know how many gallons per minute that you want for a particular size, maybe you got a 1 unit, a 1 bedroom, or a 4 bedroom, you can size these to the load. And you can see over here on the tag, that's the information that we would give you, is what kind of performance you could expect to this. And of course, that's going to be based on your incoming water temperature. Some of the projects I visited over there had big solar thermal arrays that would go into a big storage tank, and then they would have these domestic hot water units that were just pulling off these multi-thousand gallon buffer tanks, if you will, and that's how they would make the domestic water and have a boiler for backup if they didn't have enough solar stored. And I imagine there's other companies out there that are making this. I know some of the German companies like PAW makes a domestic hot water module like that also. Cogen, if you ever have a chance to look at under the hood of a really nicely engineered cogen unit, and this is the one that Lochinvar is bringing in from the Scandinavian countries, I think, is making this for them. If you take the jacket off and you look under here, there's heat exchangers everywhere inside this. They're using the coolant water from the diesel engine that's in there to pull the temperature and put it in the buffer tank. They've got one on the exhaust manifold. There's a heat exchanger. The generator, which actually gets warm when you're generating electricity and you get big loads on it, there's actually a little heat exchanger that pulls the hot water off of that. So anywhere that there's waste heat going out the exhaust pipe, going out the casing of the generator, and also in the coolant water, they pull all that and then they just store it in the buffer tank. So then you can just pull it off of that for whatever your need might be. I think they've got a half a dozen or more of these installed around the U.S. right now, this system with the cogen units and the buffer tanks or the domestic hot water applications too. So, and there's a lot of those. Typically, these are going to be on bigger applications. I know there's some other companies over the years. I think did Honda try and build one for a while. There's a couple other companies that tried to get little residential cogen units, but the numbers just didn't work out for a homeowner, but certainly a bigger application. When you think about these cogen units, they're thermally led is kind of the terminology they use. If you don't have a big thermal load all the time, like even in the summer, then this doesn't pencil out. To just generate electricity by using a diesel or a propane fired motor, it just doesn't pencil out unless you have a way to use that thermal energy all the time. You've got to have a big domestic hot water load, maybe a brew pub or something like that, where almost 24/7 there's a thermal load. That's when the numbers can start to work. And of course, depending on what you're paying for electricity. I see an application for something like this up in Alaska, where they have to, haul in diesel fuel to run generators on these remote villages. Well, gosh, if you're running that generator every day, you might as well be heating the water for the people in the village, or cover some of their heating load in the wintertime. So that's probably, a good application for a cogen unit. But the key is all the heat exchangers that you can use as much of that energy as possible coming off that. These are available. I mean, you usually have to register at these different sites that have access to these. I will say, if you've never done one of these, some of this terminology in here, you might need somebody to kind of lead you through this, because you can play around in these software programs and really optimize a heat exchanger design. It depends on the flow rates. If you can take a little bit more delta P, you can get a little bit more performance, but it's going to cost you more pumping power. So you can play a lot of what-if scenarios, and most of the time, when these programs spit it out, they'll have a couple different options here for heat exchangers that would work for that application, but there's going to be pros and cons. One might need a little bit more input temperature to get you there. You might need a little bit higher flow rates that, again, would cost you pumping power. But really, if you want to size a heat exchanger properly, you should use a program or go to the rep or go to the manufacturer and help you. I know I go online and I see a lot of these do-it-yourselfer sites that say, oh yeah, for a family of 4, you need a 20-plate heat exchanger. Well, based on what? They have no idea what what you're feeding into that heat exchanger, what you expect out of it. So it's not a very good product that you should rule of thumb. The cost goes up as you get bigger sizes. You certainly don't want to undersize it. You certainly don't want to have a problem with it falling because it's not sized properly. So, if you're good with software programs, you want to try this. This is one of the sites that I use that allows you to go in there and use their software. I think Bell and Gossett has one too, and they were pretty good on their webinar explaining how to use their program. Sometimes they don't give you all the information, but if you can, probably on their YouTube channel or something, you can pull up their heat exchanger webinar, and they go into sizing a little bit more than I will here. Now, these are some examples of heat exchangers I got out in my shop still that I've kind of collected over the years from the solar and the wood boiler industry. So starting down here with this one, this is just a tube inside of a tube. Now, this inner tube is corrugated, kind of like you see on the right here, so you get a little bit more, not only surface area, but a little bit more turbulence as the water goes through there. And basically what you would do with this is you connect the wood boiler to it, and you would just put this right on the size of your water heater, and it would just basically thermal siphon from the top nipple down to the drain connection. So you didn't need a pump on that side. It would just kind of thermal siphon through there. So whenever you had the fire burning in your wood boiler, you were heating up your tank. A word of caution, you could certainly overheat a tank. You could get your domestic water heater up to 180 degrees. You can get it hotter than that, and we've had ones where they would pop the relief valve on temperature because they got them so hot, or they can get too hot that you would want to put a mixing valve for sure on that type of application, because whatever temperature that wood boiler's running, you could essentially get that tank up to pretty close to that temperature. So if you see one of these on a job, I would highly recommend that you put a thermostatic mixing valve on whatever this is connected to, typically just a regular water heater tank. They typically call that a sidearm, domestic hot water sidearm. Now this one over here, this was an engineer that I met years ago at a solar show in somewhere in Long Beach, California. Dr. Butler was his name, worked for Lockheed for years, and he started a little solar company. He said, well, I'd like to make a heat exchanger that I could turn any water heater into a heat exchanger tank for solar. So he makes the thing he calls a solar wand. And basically you take the nipple, the cold water nipple out of your water heater, and you screw this in. And so now your cold water, this is a bronze elbow here that has been discolored. Your cold water can go into the tank around this nipple, and then there's a tube inside of a tube here. And there's the tube that's inside there. So you hook your solar up here. So your solar goes in here and out the other one, and you heat just your regular water heater with this little solar one. It's not a super high performance heat exchanger, just based on the size of it, but you could essentially on an electric tank, what you could do is you could put a timer on your electric tank and turn it off until say 3 o'clock in the afternoon when you come home from work, so that your solar wand has all day to generate that domestic hot water if there's no sunshine all day. An hour before you get home, the electric element would kick on, and it would boost the tank up that way. So that was a pretty clever. He still sells them. I think his son's taken over the company now, but you can still find these online. What I did with one of these once is I had a house that they wanted to do a little radiant heat for just a bathroom. It was a typical 5x7 bathroom, ceramic floor. Said, well, yeah, you don't really have a good application to put in another boiler or any kind of heater. Didn't want to use electric. So I took one of these and I put in his water heater, and I used it for a heat exchanger to pull heat out of his water heater to run a little small radiant floor. And it's been working for 20 some years. I'm assuming it's still working, but you know, it can be used to put heat energy into a tank or take heat energy out. So if you want a little bit of energy to run a domestic water load, or you know, to pull it off for a radiant load, that heat exchanger can be used in either direction, basically. We're doing for time here. Yeah, pretty good. Now, one of the other things that's intrigued me over the years are these drain pipe recovery systems. And you look at these and you say, really, how much energy can you recover from a drain pipe? Well, properly applied, these things can be pretty powerful. And of course, it depends on what you're paying to heat your domestic water. But basically, all we're doing here is, and this probably started back with the power plant heat exchangers, that they're scrubbing all the waste heat off their stacks and different things. So basically, you hook up your drain line here that goes through this, and whenever hot water is running down the drain, you can pull some of that heat energy and put in your domestic water. And I found today still 3 companies that still have websites up that are still making these. These kind of come and go, you know, as energy costs get really high, when oil prices go up and things like that. All of a sudden, all these kind of free energy type of devices come back into play here. But this company actually makes one that's unusual, but it is can be used in a horizontal piping, because you don't always have an application in the home where you can get into a vertical pipe to put in a vertical. So the key is always with every heat exchangers, there's just a lot of wraps around this here. The more wraps you have, the more contact you have, the more heat exchange you have. So they actually use a square copper tubing. I don't know where they get that. I think Wolverine company makes a square copper tubing, and they must have a mandrel or something that they bend that square copper tubing. So now you've got a lot of good surface area by using the square instead of a round tube, so you can grab as much heat. And they're claiming, if you read through this, up to 24 degrees, you can raise the temperature of your incoming water through one of these devices. So, you know, in the wintertime, your water might be coming in at 40 degrees. You can boost it up 10, 15, 20 degrees before it goes into your water heater, whatever your final domestic hot water source is. That's, you know, for the cost, if you do the numbers on them and you read through, if you go to their website and read through it, and they put some examples, if you're paying, you know, 15 cents a kilowatt hour for electric water heater, you know, and you know how much water you're using, you can kind of pencil it into their formula there and see that these things for the money can really have a pretty good payback. So again, you got to have the right application. So me, being frugal and cheap, I said, I wonder if I could make something like that. So I started out, even though I don't have a very good shop here yet, I have enough power that I can run some of my tools. So I had this idea to get an 1¼ inch U-bend there and take my little T-puller, my REMS T-puller there, and just pulled out a bunch of connections here on the top and bottom. And this 1¼ inch fits exactly, just perfectly around a piece of 2½ inch copper pipe. So I had a good snug connection there, and then you'll see as we go here, I found a way to put the tubes against the side of the copper tube. So I've got it installed. I'm going to put a BTU meter on it. I've got a little bit more work to do. I'm going to put some clamps on this to get those nice and tight against the copper tube. And then I'm going to put a BTU meter on here, and I'm going to run this and see. So I've got my my wash machine drain going in here and my kitchen drain. I couldn't get to a shower drain, but I'm thinking, well, I'll just try those. And by the way, 2½ inch copper matches up pretty closely to a 2 inch ABS or PVC as far as the OD, so it clamps in there nice and tight. So I'll report back when I get a little bit of data on how my little homemade heat exchanger. It's about 6 feet tall there. I had the pipe here, so it didn't cost me a lot to put this together. A little bit of welding gas to braze those in there and stuff like that. So I'll let you know how it goes. So a couple things that before I get in this heat meter that I want to talk about, when it comes to selecting what type of heat exchangers, there's pros and cons of the different type. In fact, let me go back a few slides. I wanted to touch on this a little bit more. I have my little cheat sheet here, and I forgot to go back to, oops, sorry. On the 2 different types, being the tube and shell, or the shell and tube, some people call them, and the flat plate. Really what it comes down to, you'll find the flat plate is probably one of the most efficient, just because there's a lot of surface area. And they've really engineered these over the years. They've gotten to the point where they can actually change the size and the shape of the little chevron. If you've ever cut one of these open, you've seen these plates, they can change the size and the shape of that to really optimize the performance, the thickness of the plates in there, the number of plates. So that, of all the ones that I've looked at, claims to be the most efficient. Now, the downsides to that is it's really just good for clean liquids. You wouldn't want to put like fibrous, like the paper and pulp industry uses heat exchangers. That wouldn't work so good through that. You wouldn't want to put paint or heavy oils or something like that. So they're really, they're best for, clean water. Some brackish water can go through there. Sometimes you'll see salt water going through them, but they don't work well when you have to have a high viscosity fluid or something that's got chunks in it. Waste sewage water, for example, can be used for heat exchange too, and that wouldn't work so well for a plate heat exchanger. One of the questions that came in, can you oversize a plate type of heat exchanger? And I didn't know the answer, so I went and I found some good information on Lavelle's site today. And they said, in fact, you can't, because the key to a flat plate heat exchanger is you want turbulent conditions in there, because when you have turbulent conditions, that's where you're going to get the best contact with all those shapes in there. That's where you're going to have the best heat exchange. And the key to a plate type of heat exchanger is you've got two moving flows. You've got a pump flow. You can't just gravity feed through a flat plate heat exchanger. So you got a pump flow on both sides. So you've got good turbulent conditions on both sides of those of the plates in there. So the key to that is having them pumped and sized properly. And if you oversize it, what they say can happen is you can foul up those plates. So let's think of a domestic water application where you've got really hard water. Maybe you've got 20, 30 grains hardness in your water. And if you oversize that plate heat exchanger and you're not scouring those plates clean, you don't have a good flow velocity, or what they call channel velocity, going through all those shapes in there, you can start to get a little bit of a coating on all those surface areas in there, and then your heat exchanger performance starts to drop. Now, you'll get a call on the phone that, I'm just not getting the amount of hot water out of my ModCom boilers are famous for this. Over time, the performance of the hot water drops off. It means the heat exchanger could be fouled. Got to run a cleaner through that, clean that hard water buildup. So those are some of the things they cautioned about. If you oversize it and say, well, the price was right, I got 3 times the size that I needed based on the software program, but in fact, you could be going the wrong direction. So just be aware of that. There are some areas that you could get in a little bit of performance. So if you are going to start going with, paints or heavy fluids or something like that, this type of heat exchanger, this type is going to be better. They both were developed from the research I did today, the early 1900s. I think the power plant industry is where those came from. So that was one of the questions that came in about oversizing. Again, this will show you that as you start putting data in here and you start putting in a fouling factor on that. And if you know how to enter that information based on hardness of the water, you can see as this number changes how the performance and the efficiency of this heat exchanger is changed by that. So, we want not only a lot of surface area, but we want clean surface area to get the best heat transfer. Let me see if I had anything else on that. Yeah, so what it's going to come down to is you start going with higher flow rates, it's going to cost you more pumping power. So that has to come in. Now, certainly for these little residential applications, that's probably not going to be a deal breaker. You're not going to get out of the typical little wet rotor size pump. But, if you're doing a large application, I'll show you one that I visited here a while ago, that can make a huge difference if you're starting to run 20, 30 horsepower pumps to run all this. You want to pay attention to that. So let me get back to this one here. So yeah, I'll let you know how this works. I think it's going to do something. I don't think it'll be as efficient as some of those store-bought ones where they've got a lot better tubing contact and a lot better surface area, but this is why it's important. If you want to know that information, I could guesstimate what's going on, or I'm going to put one of the Caleffi BTU meters. So basically, here's a picture of one installed on a job. Excuse me. If I know the flow rate going through there, and I've got 2 temperature sensors measuring my delta T across it, really that's the information I need to come up with a BTU performance or output on that. So that's really the best way to know exactly what's happening. And over here, this picture on the right, this is actually a lab over in Italy in our Cula Rossa building, this red cube building that we have over there that we do a lot of development performance testing. You can see on these, we've got solar arrays up on the roof here, and we put BTU meters so we know exactly what these different, like the evacuated tube compared to the flat plate type of collectors. We wanted to see what the difference in performance is. Well, with the BTU meter, you know exactly. You can go there every day and look at the output. So we offer that BTU meter if you've got an application for that. We're starting to see more and more people doing district systems again. There's some projects up in Canada right now that are doing district systems. That's a good place for a BTU meter if you want to start billing your customers, your clients, your tenants, whatever, for the actual energy they use. And that, as we start to get in these net zero homes and stuff like that, we're seeing BTU meters are having a part to play in that here. I'm going to let Max talk a little bit about this. So this is a system in DC.
Yeah, so this is a water utility, and they've got this, the brand name is Shark up on the top line there. They've got this heat exchanger, and they're exchanging the wastewater from the city that would have just gone, out through out of the city. They're using the heat from that to power the whole heating and cooling load of that 150,000 square foot building. So a pretty good use of something that was just flowing to waste under the building, and now they don't have to pay for natural gas service for heating and cooling that building, and really takes the electricity load down as well. So it's kind of a cool project.
Yeah, and so that would be an example where they would use a heat exchanger, obviously, that could handle that type of fluid going through. And it looks like from the package, as I can see in the picture, it'd be fun to visit that someday, that they've got that pretty well engineered and pretty well thought out. Another job that I came across when I was out in Nevada years ago doing some training, I met an engineer at one of the trainings that had designed a system for one of the towns in Reno that they were actually using the water mains and pulling energy off of that to run some heat pumps. And they actually pulled it to a point that they actually froze the city water mains. They pulled so much heat out of it with a heat pump that they froze the main, and they had to extend that around the whole block instead of just a short area in front of the building to pull that off. So just another example of a heat exchange where they're using water that's already in the ground, that's already supplying, domestic water to the city, and just pulling some of the energy off of that to run the heat pump. So it's kind of along the same lines that system's already in place, in every town in America. There's energy to be had both from the wastewater and the sewer, but also, from the water mains for doing cooling loads and stuff. All right, so I think we can do a little trivia here, and then I've got a couple more slides coming too. So I'm gonna go down one more slide. All right, so this is what animal can maintain their habitat home between 91 and 97 degrees, tight delta T there, when the outdoor temperature is between -40 up and 104 degrees, which we've seen this summer here in Missouri. So it's an example of heat exchange. We're going to show you some pictures of this. So we'll give you a second or two, and Mary's going to run this poll, and that's the winner's.
Or just type your answer into the chat.
Yeah, in the chat, type it in there, because we're not going to open the mics with the group size that we have today. So we'll give you a couple seconds to do that.
Okay, we've got 3 answers in. We're getting a bunch now. The third one to come in is correct. So I'm going to read through a couple of these. Oh, we got a bunch of answers. So bear, chicken, honeybees, frog, mouse, beaver, brown bear, bee, woodchuck, and human. So what's the correct answer?
It's the bees. So
that was Colin Wonder was answer number 3, and it was correct for honeybees.
Attaboy, Colin. Maybe he's a beekeeper. But so this is another first for me. This summer, Max and I decided to get some livestock, and with the size property we have, we couldn't put a lot of big livestock on. So I don't know if bees are really considered to be livestock, but we bought some bees. Somebody gave us these boxes, and we went and bought a colony of bees, and that's my beehive in the backyard there. And you can see at night when it gets really hot at the end of the day, I even put a shade over it for them. They beard up is what they call this, where they get out there and they actually flap their wings, and they're trying to maintain the temperature of that inside that box by just flapping their wings. And they can sense that kind of temperature gradient and keep it exactly where it needs to be. So that was a pretty amazing heat exchange feat, I would say, when it's over 110 degrees here in a couple of days, that they're maintaining that hive temperature. And certainly this winter, when it gets down below 0 here, same thing. The honey that they've stored over the winter time is their fuel source. You got to have a fuel source to be able to do that heat exchange, just like the human body. I mean, we eat food, and as a result of that, we have energy, and we also give off 400 BTUs at rest, just from the food that we consume. So yeah, we'll get that copy sent out to you. Thanks, Colin, for playing and for always participating also. So what else we have? I'm going to go through a few more questions here. I want to hit some of these typed in questions because I know people tune in and they like to know that we read the questions and replied. So we talked about oversizing the heat exchanger. One of the questions is, what's the best size for a heat exchanger? Again, I would go to one of the software programs or go one of the reps at the companies or go to the manufacturer directly. Most people, especially this day and age when they're still you know, in their offices or at home and stuff, get back to you and can help you with that. So strainer and mesh requirements, that's a good question, and it really depends on what you're going to be connecting to. If you're connecting to a residential hydronic boiler that's in pretty good shape, it's copper pipe, there's not a lot of rust and debris in there, generally a 20 mesh is assumed to be adequate for that. You know, the thing with mesh type strainers is the finer the mesh you put in there, the more that's going to plug up and the more service that's going to be required. So at some point, I'm of the opinion it's better to put a dirt separator than a Y strainer as a protection device, because with a dirt separator, you're not really plugging up the mesh or reducing the flow. You're separating the particles down to the bottom of the chamber, and you won't have as much issue with reducing the performance or service issues that you might with a Y strainer. So certainly we can help you with sizing a dirt separator, and you'll have a magnetic function in the dirt separator, which I haven't really seen in a Y strainer yet. Certainly not a steel Y strainer, but with that magnetic separation function, even if you have really small particles of magnetite or something in there, we're going to make sure that we keep them out of the heat exchanger where they can cause a reduction in performance there. I had one question I wasn't able to answer there. What's the best BAS algorithm to configure for reverse reset control on a shell and tube to steam? Starting to get out of my comfort range, both with the steam and the algorithm on a building automation system there. So again, I would steer you to the people that manufacture both the equipment that you're putting in for the heat exchange, as well as the people with the building automation as far as what sensors and how they could program that to do the best job. Again, that would go to where you would want to have some ability to know what's going on with the performance of that. A BTU meter, if you had a BTU meter showing what's coming out of that, you can maybe configure your control to optimize the performance of that. So then there were some questions about minimum flow rate through a heat exchanger. Somebody said, well, I can't get enough minimum flow through the heat exchanger to keep my boiler satisfied. Maybe they've got a boiler with a flow switch and a minimum flow rate. Well, yeah, obviously you've got to either have the heat exchanger that can move that amount of GPM, or maybe a little bit of a flow bypass through there that you can, you know, with a balancing valve, you can make sure that the boiler's getting adequate flow to stay fired up and you're getting as much as the heat exchanger. Sizing it, somebody said, do I size it to the boiler or to the load? Well, you should size it to the load, because that's really at the end of the day, if you have a boiler that's bigger than what you need to cover the load for the heat exchange through the plate heat exchanger and maybe the heating or whatever else it might be doing, you really need to know what the load. It's kind of like when you do a heat load on a building. You know, you should really never size a boiler or pump or any of the equipment in the building until you do a heat load on that building, because that's really the key, the roadmap to the success is knowing what the load is and sizing it perfectly to that. Any questions coming in, Max? Let me do a couple of those since I'm on the question mode here.
Sure. So the shop that you had in Missouri with the plate heat exchanger, so how big did you size that? What were you running off of that plate?
On the that instantaneous one?
Yeah.
Yeah, so I used a 5x12 20 plate, and here's what I was doing. I had it on my solar tank, and my solar tank in the winter months would only get up to 120 degrees. So what I did is I went to, and actually Siggy helped me size it, what's called a close approach method. And what a close approach means is I want my B side, my water coming out of that, my domestic water coming out of that, to be pretty close to 120 degrees. I don't want to get much colder than that for my domestic hot water. So when you use a close approach sizing method, what you're going to find is the heat exchangers start to get pretty large. In fact, maybe that was a 30 plate. I had two different ones. One was up at the house and one was at the shop. I think the one on the shop in that solar tank was actually a 5x12 30 plate. So that's the key, is you got to know what kind of temperature you have going into it. And of course, you know, it was just the two of us. I didn't need a lot of domestic hot water. A gallon and a half was plenty for us to take a shower, or actually do a shower and one other, maybe the dishwasher running simultaneously with the shower. So yeah, it was just a flow switch and a little heat exchanger that I bought, and I think I had a little Grundfos Alpha on the pump. I used to have a picture of that. I don't think I can get to it quickly, but it worked fine. What I noticed is that if you start looking at the ModCon boilers that are the combi versions, those little modules that I showed you a couple slides earlier, those are actually pretty small heat exchangers. I was surprised when I took one of those apart for the first time. It must be metric size because I measured it to be like a 3x8 size on those. I'm thinking, gosh, how do they get so much performance out of such a small? Sorry about that. That's a little bit bigger there, but in a ModCon boiler that I've seen, they have a 3x8, but the key there is they take the boiler temperature up. Some of them will go up a 180, 190. So if you've got 190 going in and you're just trying to get the water to maybe 105, 110, just enough to take a shower, just enough to be hot enough to be warm when you're in the shower in the tub. So now you've got a pretty big delta T to work with there if I have 190, and I've got the full output of the boiler. So I'm going to switch off the heating load, usually with one of these diverting valves here. I'll switch it off the heating load, so all the output of the boiler goes to the heat exchanger, as well as the highest temperature that that boiler can comfortably run at. And I think some of the ModCons, like I say, maybe they're set at 180, but I've seen them creep up to 185, 190 just before they're ready to shut off in domestic hot water mode on the combi. So the sizing, and I would say for that, you don't want to oversize for that because you don't want to follow that heat exchanger, because all the places that I've lived over my lifetime, we've had hard water, and if you take a water heater apart that's been in for 10, 15 years and dump it out, a lot of scale and minerals in there. And what happens is when you have a hot surface area, like if you're running the A side of that heat exchanger, hitting it with 190-degree water, the minerals in water really precipitate out, really are attracted to that high surface temperature on that plate with that 190-degree water, and that's where you see the falling. Now, that being said, I was recently at a shop up in Montana, and they had a combi, one of these modules that was inside a combi boiler on the workbench there. They said, yeah, we were having problems with this, not giving us the hot water that they expected, like 6 months into the installation of this combi boiler. So they called the manufacturer, and he said, well, check the sensors and check this and make sure the shuttle valve, and they checked all the things, nothing was working. They changed things, it still wasn't working. So finally the contractor took the whole thing apart. He took these little Allen screws out here and took it apart. And what he found out, and this was interesting, it was put in on an older building that had previously had some of the a rubber tube on the job, and it actually fouled up the A side of the heat exchanger, the boiler side of the heat exchanger. When he tipped it over and shook it, all these little granules of black brownish chunks of something came out of that. And so you assume that it's always the B side, the domestic water side, that's going to fall up. But in this case, it was actually the boiler side, the A side of the plate heat exchanger in that ModCon that had fouled up to the point that they're, getting half the amount of domestic hot water that they expected or needed or whatever. So sometimes you can be fooled by thinking it's always the hard water that's causing your, and it's true for, any type of heat exchange, whether it's a combi boiler or just a shell and tube or indirect tank or reverse indirect tank. It's all sensitive to that scaling of the metal surface areas. So another one?
Yeah, some advice from Dan Clemens to put some heat transfer paste on your heat exchanger over here and wrap it with insulation. So
yeah, excellent idea. I'm going to do that. I'll get some of that, a tube of that heat transfer and squirt it in there, get some hose clamps, and then wrap it with some 1-inch insulation. I should try it before and after just to know how much that's changed it. Well, thanks for that. That was a good tip. Thanks.
And then this one comes up a lot. What's the best material for a pool heat exchanger, and maybe even the type of pool that uses salt water instead of chlorinated water?
Yeah, so I mean, most of the heat exchangers, I think, for pools that I've used over the years, like Triangle Tube makes one, a couple other of the boiler companies, I think Weil McLean's had one over the years. I think they're just 304, 316 stainless steel, but I've heard for salt water or for some of the other applications that maybe a titanium stabilized stainless or maybe even a titanium heat exchanger. I would certainly talk to the manufacturer of that heat exchanger. I know in some of the, Mark Etherton, some of you guys know him up in the mountains, he's worked on some of those hot spring heat exchanger applications up there, and they've had a lot of problems with heat exchangers, and they've gone to ceramic heat exchangers. Number one, for higher temperature applications, they work a little bit better. Some of the flat plate heat exchangers are limited on the temperature on the A side because if they're put together with the rubber gaskets, like the bolt together type, the limitation is those rubber gaskets or EPDM, whatever they might be. Now, a brazed type can go a little bit hotter, or if you're going to super high temperatures, like on a, maybe a power plant regeneration or something like that, that's where they go to shell and tube type of heat exchangers, because they don't have a gasketed assembly or connection in there. So, but the ceramic, I would imagine they're expensive, but that's another option. But yeah, I would talk to a professional if you have a special application, or if you're doing paint or sewage or something like that. You need to make sure you're getting the right application.
And there's a company named Bowman in the UK that makes pool heat exchangers that you can completely take apart and power wash out or something like that. I don't know, but of a really high grade of stainless like that.
Yeah, I think they were nicely insulated and stuff. They were a nice looking package. I recall the ones that company makes specifically for a pool. What I do remember, the ones that the boiler companies would sell, you didn't have a lot of size selection. It was just kind of a miniature tube and shell with big openings on both ends, 1/2 or 2 inch, and didn't look like there's a lot of exchange area in there. But again, if you're running the boiler at 180, 190 degrees, you got a big delta T. You just need to have a big opening so you can, pump the pool flow rate 35, 40 gallons a minute directly through it. So, yeah. All right. Let me show you this over here, a couple things that I had another idea for a homemade heat exchanger. So if you have a tank with a 2-inch connection, that's just a 2-inch T there. What I did here is I took some CSST gas flex type of tubing. This happened to be the solar tubing that we had. This was a 1/2 inch. And what I did is I annealed it. And what you do when you anneal copper tube is you just heat it up. You don't have to get red hot, just heat it up a little bit, and it softens it so you can bend it really tight. So I made this heat exchanger that I could put inside of a 2-inch tank, and then I took a double tap. Let me see if I get the picture here. A double tap bushing here that I can bring the 2 connections out and connect to them out here with a little O-ring seal in the ridges to do that. So not very big. Again, I was trying to get somewhere between that Butler solar wand and have to buy a bigger, flat plate or a tube and shell heat exchanger. So if you're like playing around with things, that's one thing that you could do, is just take some stainless steel tubing, heat it up. You can see how I discolored it when I heat it. It was shiny stainless, but that's how you can soften it to make it so you can get a really tight bend at the end without kinking it there. Then over here, heatinghelp.com. It's an old, I was thinking about offering some of those again. Sorry about the dirt. These are all different ModCom boiler cutaway sections that I got over the year. I think that's a Beastman. I think this is one of the Dunkirk or Utica. You can see what they're trying to do with all these is they're trying to get a lot of surface area. They kind of crimp them and they put some shape to it again, that they're trying to get good transfer in there. The same thing here with the dimple thing, so they can keep a space there for the flame to go through, but it's all about the surface area. And so this is one of the common, let's call it the Munchkin, because most people recognize that name, the little Gianomi, Cermeta, whatever the brand is these days, heat exchanger. You can see what Beastman did is they just kind of played on that coil type of heat exchanger and just changed the opening size of it so they could have a lot less pressure drop and get a little bit more flow through it. So those are a couple examples, but what you'll find, and one of these I had was a used one, as these start scaling up on the inside from bad boiler water, a lot of minerals or high TDS water in them, you'll start scaling up that surface inside there, and then you don't have a good heat exchange. And that's when you see a ModCom boiler where the metal starts to discolor. It's because, again, heat exchange has been hampered by you can kind of see a little bit of it in there, by the buildup of the minerals in there. And that's, again, the time to put a cleaner through it. We're also going to lobby Aaron to come out with another belt buckle. Some of you have the Heating Help belt buckles. I'm thinking now with the 3D printers, you could probably squirt one of these out of some exotic material like ceramic or titanium or something like that to keep the weight down on your belt, right? All right, so what else do we have here?
We've got a couple more questions.
All right, we got a couple minutes.
All right, so another one about cleaning out a heat exchanger if it was subjected to the rubber tube.
Yeah.
Have you ever run across that?
Yeah, all the chemical people seem to have pretty good boiler cleaners these days. I like Rohr just because I know that company. I've worked with them, Fernox, Sentinel, Hercules. Usually if it's a boiler side, it just needs most of those boiler cleaners are just a really strong detergent. They're a soap at the end of the day, and they do a pretty good job of that type of debris. Now, if you have one that has a lot of white mineral scale buildup, I tend to like the acid type of cleaners like Hercules Sizzle. It's actually a drain cleaner, but it's an acid that can be used in domestic water. It says right on the bottle, safe for domestic water. So if it's a scale buildup, a white lime scale buildup from just hard water, sometimes the acid-based cleaners will work a little bit better than the soap-based cleaners. So yeah, I mean, squirt a little bit. They make it in aerosol cans now that you can squirt it directly in your boiler, run it for a couple days, flush it out. You know, save the water that you flush out, and you'll see if you've got what's coming out of it. You've got a good job cleaning it out. Some of those cast iron boilers, what happens in a boiler that's a big wide open chamber like that, there's not a lot of flow velocity going through that boiler. And what happens is that stuff settles out to the bottom of the section. And sometimes it's hard to blast that out without getting in there with some kind of rod or something to, you know, actually get some good flow velocity down there and actually move it out. And that's usually when you hear a cast iron boiler start percolating, you know, that popping, banging noise, it means you've got a lot of sediment in those sections, and that's it's not always easy to get out of there. So cleaner through it, power, you know, flush if you can with a little half-horse transfer pump so you get some pretty good flow velocity, and that should do it. Got one or two more, or else we'll go through the
I think one more, asking about like a dirt separator with the magnet on the boiler return for anything that's going through a heat exchanger. What's the recommendation there?
Yeah, you know why the magnetic thing is so important these days that you start learning about or pay attention to it is as we start seeing more and more ECM pumps, and I think we're getting close to the day when the PSC type of motor circulators, wet rotor circulators, are probably going to disappear. I see Taco just came out with an energy standard on some of their ECM pumps. Really, the magnetic function to me is just to assure that there's nothing going to get inside those ECM permanent magnet motors. We've taken dozens of different ones over the years apart of all different brands, and some of that magnetite that, again, we're talking magnetite down to a 0.5 micron. That's like a thinner than a piece of hair on your head. That can get through the seals on the pumps. That can certainly get through the wet rotor can. So to me, the magnetic separators is mainly to keep an eye on and protect those ECM permanent magnet pumps. But every one that we put in on any job that we put it in, stuff comes out, stuff that's been swimming around in there, stuff that's reducing the heat exchange if it's settling into your radiators and your boilers and your tube, like the ModCom that I just showed you here. The magnetic separator just takes it one step further than just a Y strainer or a dirt separator by pulling the little particles out that you won't get out with a strainer, that you won't get out with a dirt separator. They're just too fine. It's the boiler ink. If you see black water coming out of a boiler, we call that boiler ink. And really, it's got metal. It's almost like it's got Etch-a-Sketch particles inside of it that makes that water black. And that, if you put a magnetic device on that and you run it for a day, you'll see that black inky water is all of a sudden clear water because you pulled all those little particles out with your magnet. Okay, so this is another series that we're running. Cody's running most of these. It's taking 5 minutes for 5 things that you want to know. Again, go to the Caleffi website and you'll see all the different educational things. We started doing a lot more of this stuff with the COVID shutdown. We said, okay, we want to keep the information coming out to you when we can't be in front of you as much as we used to be, although we're starting to travel a little bit again now. To that end, we also have a podcast that Greg and Dan, our tech support people back in Milwaukee, have been running a podcast and doing some pretty good topics there, involving you folks in those also. So give that a listen. If we can help you with any of the things that we talked about tonight, or any of your jobs, any of the things hydronic related, that's our tech support team there. Give us a call. We're glad to, you know, answer the phone and help you however we can. So I think that's where you can find us. We're on social media, all the different places that we hang out. All right, well, to make a long story long, thanks everybody for tuning in tonight. We had a great audience, and hopefully you got something out of that. Any comments you have, you know, we'd love to hear from you. See pictures of the jobs that you're doing, send them in, and we'll share them with everybody we know. So anything else, Aaron or Mary, Max? If not, I think we're gonna call it a wrap. Thanks, everybody.